welcome Sebastiano Tronto, our world record holder for the Rubik's Cube, who managed to solve
Hello.
it in only 16 moves. Hi, Sebastiano.
Hi, hello. Hello, everyone.
So tell us a bit about yourself. What's your job at the University of Luxembourg?
Yeah, so I am a PhD student, which means I both study and do research. After finishing my master's degree, so my 5 years of university, I decided to start doing research, and that's the first step. What I do is what other scientists, other mathematicians do. We try to solve problems and come up with our new theorems. It's just that I'm young, so I just try to solve the easy problems or maybe collaborate on the harder one with more experienced professors.
And what's your PhD thesis about?
Yeah, so I'm working in number theory, more specifically with elliptic curves, which are kind of geometric objects, which also has arithmetic properties. It's very interesting. And in fact, they are very useful in practice for cryptography, for example. So if you're using WhatsApp or maybe other messaging app, let's say they are end-to-end encrypted, it's almost certain that they're using elliptic curves in one way or another. So your phone is doing math without you knowing. To secure your messages, to make it so someone that intercepts them cannot read them. I don't study these cryptographic applications. I mostly focus on the theoretical properties that then can be applied. But yeah.
But today we're here because of your hobby. Can you tell us a bit more about that?
Yeah. So my hobby is speed cubing. So what I like to do is play with this sort of puzzles. Yeah, so this is a Rubik's Cube. I think you've seen one. What I like to do is, well, basically to scramble it and solve it over and over again to try and get faster, to learn better techniques, to be more efficient. And then I share these results with my friends, and I will even go to official competitions.
And what do you like about this speed cubing?
Yeah, so you might think it's a bit boring, because if you don't know how to do it, you see, well, it's just the same process, you do it over and over. But it's really, once you start learning more advanced things, you see that there's a lot that you can, it's always different, right? There are many different configurations. And even though you always use the same strategy, it's really, every time you do it is a bit different, right? But one thing that I really enjoy is that it gives me an objective way to measure my improvement, right? So if 2 years ago, I could solve this in 20 seconds maybe, and maybe now I can do it in 10 seconds, right? So I time myself and there's a number, and as I become better, this number becomes lower. So it's really a good way to have feedback on your skills. That's what I like. And then I also like the community, because there's a lot of people that share this passion with me. And yeah, it's very fun.
Can you maybe give us a short demonstration of this skill?
Yeah, of course. I'll have to mix it up. Maybe I'll call someone to mix it up for me. So you see, I don't just make moves and then make them backwards. Let's see, someone here, assistant. We can have some moves. I'm not looking at what it does. Okay. Yeah, so, well, maybe I can time myself. So at official competitions, I'm given 15 seconds to look at the cube before starting, so I can prepare like for the first step. Let me see. Okay, maybe I can start now. Is it okay? Yeah. Yeah. This was a good one. Usually I take more like 8-9 seconds. This was just 7 seconds, but a bit lucky, you know.
So maybe that's also the adrenaline of the today's event.
Yeah, it's possible. Sometimes it's good, sometimes it's bad. Sometimes there's too much adrenaline and I just shake too much.
But that was really fast. Can you maybe do it again? So we have a chance to follow.
Let's call again the assistant. Oops, did I turn one? No, it's fine. Assistant. Yeah, not looking.
Not cheating.
Okay, let's see. Okay, let me.
Don't forget to take the time.
Yeah. Okay. This time was 9 seconds.
But still very impressive. I mean, who can?
Yeah.
So what's the trick?
So yeah, it's not like it's a magic trick. There are methods, different approaches. And of course, when you learn, when I learned the first time, it was much slower. It took me minutes. Now it takes years of practice to do it in a few seconds. But in principle, it's something that really anyone can learn. You just, you can go online and there are many tutorials on YouTube or even written. Yeah, so you can look it up and see how it works. There are a lot of different of these methods, from the more simple one to the more complex ones, like what I use.
Can you maybe teach us now also?
I can give you the basics, yeah. Then learning how to solve it completely takes maybe 1 or 2 days, you know, but now I can start. So what I like to do with a cube, the first thing I like to do is to take it apart and show how the internal mechanism works, right? Because otherwise you just see colors, but you don't really see how the mechanism works. So let's take this apart, but don't worry, I have more, and then I can always put it back. Okay. And you see, I took away one piece which has 2 colors, right? This is called an edge piece. Maybe I'll shut this down. Yeah. This has 2 colors. It's called an edge piece. But there are also pieces that have 3 colors, and these are called corners or vertices. And if I take it all apart, you'll see that. Well, just give me a minute. Oops. Well, it's fine. Yeah, and you'll see that there are many of these edges and corners. And then there is this, well, okay, there is this part here, which is the so-called core of a cube, which consists of some pieces and the internal mechanism that makes everything turn. These pieces here are the center pieces. So if I take the cube that is not completely destroyed, you see that each side has 9 pieces, and the central one is the pieces that are here, right? And all the others are either edges with 2 colors, or like this, or corners with 3 colors. So yeah, that's the basic idea. And then already knowing this helps you, because if you see, you don't have to think about just the single colors, but of pieces that are composed of 2 or more colors. And the central pieces are fixed to this structure. They don't move relatively to each other. So this tells you that when you start to build, for example, the orange face, you don't have to look just at the orange color, because any piece, for example, this one, which is orange and green, has 2 colors, right? So when you put it in its own place, close to the orange center, also the sides needs to be close to the green side needs to be close to the green center, right? So when you start, for example, let me take another one. Let me take this here. Let me mix it up a bit. The first step in the beginner's methods is usually building a cross, such as, let me see, such as this one. No, this one doesn't matter. Can you see me? Can you see the cube? Maybe like this? Yeah. Yeah. So a cross like this, where the central 4 pieces are in correct position. But when you do this, you also have to pay attention to the side pieces. For example, this piece here is green and white, and it connects to the white center and to the green center. So this is correct. But this piece here is white and blue. And here it's the white is okay, it's part of the cross, but the blue here on the side is close to the orange. So that's not very good. So this is the cross here looks correct, but it's not. So what you have to do is to, well, change their position. Now I did it quickly, but yeah, and so that you have not only the cross, but also the side colors that are correct. So if you want to try and do this, take your time. The first time you do it is going to take some minutes, as I said. But then you'll see that you can like just match 4 pieces here, and that's fine. Then the beginner's method continues by inserting the corners. of the first layer. And again, what you have to pay attention to is not just to, for example, here I just inserted this corner here, white, it continues the cross colors, but you also have to pay attention that the side colors are correct. So blue matches the blue, and the red matches the red. Yeah, and for example, if I do something like this, you see that here I have white, but if you look at the sides, then orange matches with green and blue with orange, so this is not correct. It has to be in another place, like here. Yeah, and now I just do it fast, right? So we can see how the end result is. This is the first step of the layer by layer method, which is one layer, which means not just that it's all white on this side, but now I did the white face, but you could do another one, but also that on the sides, all the colors are matching. It's like one solid block, not just one side, right? If you do side by side, then you see that you get stuck. But if you need to do like a solid block of pieces. And then, so this step here, even in the most basic method, can be solved like, we call it intuitively, when you don't really need to follow a specific sequence of moves. But then at this point, you see you get stuck, right? Because any move you try to do, you're going to break this first layer that you built. So what you do for the other two layers, you need to learn some specific sequences of moves that help you insert the pieces, like fix the other pieces without breaking what you did so far. This part is a bit more boring, so I'm not going to teach it to you now. But yeah, it shows you that even the more advanced methods have some step which requires you to think and like find out your own moves, and some other steps that require you to recognize a pattern and apply certain sequences of moves to solve it.
Okay, so that was the beginner's way of solving the cube, but you're using another method, right?
Yeah, what I do is a bit different. There are also many advanced methods. The one I use is called Ru, from the name of a person who invented it. And what I do is, instead of building cross, the first thing I do is I build like a rectangle of pieces, like this. So this 3 by 2 by 1 block. It's still a solid block of pieces. Then what I do is I build the block on the opposite side of the cube. Yeah, so I have this first rectangle that I built and the other one without breaking the first one. Then, as I said, even the more advanced methods require you to learn some sequences. So I have to pick to solve I want to solve the corners of the last layer. So I have to pick one out of 42 sequences that I memorized to solve the corners of the last layer. And then finally, I can solve the remaining pieces, which are only edges and, well, the centers, but they are fixed, using only the middle layer and the upper face. Yeah, so this is, as I said, this is a bit more advanced, but it's also more fun to use. And it's not the method that most people use, actually. This was used, for example, by the second place in the World Championship 2019. But most people use a method called CFOP or Friedrich, which is derived from the layer by layer method, but it's more complicated.
Okay. And how many combinations does a Rubik's Cube have? Can one have like two combinations twice, or a combination twice, basically?
Yeah, so there's a lot of them. So no, it's you cannot get the same twice. It's like almost impossible. I mean, there's 43 quintillion combinations, which is it's 43 with 18 zeros after it. This number is called, in French or in German, it's called trillion, I think, because in most European languages, we use million, milliard, billion, billiard, while in English, they say million, billion, trillion. So 1 billion in English is 1 milliard in French. So there's this from, but quintillion is the right word in English, yeah. Yeah, maybe I can show you how this number comes up, right? It's
yeah, sure.
Let's see. No. Let's take notes. Okay, so is the camera on my iPad? Okay, yes. Perfect. Yeah, so how do we do this? Well, here we have our cube. But now it's just on the screen. Let's try to draw it a bit. I was not the best at art class, right? I'm more of a math guy.
I think that doesn't matter. One can understand what you're talking about at the Rubik Show.
Yeah, so that's the idea. This is a cube, not very nice, but yeah, the idea is that we want to count how many positions there are. I showed you that there are edges and corners. So the centers are fixed. So they're always in the same position and they don't count. Edges and corners. So an edge can always be in an edge position. So an edge like this one, this piece here, just two colors, will always be in one of the edge positions. It cannot be on the vertex, right? On the other hand, corners can only be on the vertices. So we can consider them separately. So I will show you first how many combinations of edges there are without considering corners, and then we'll do the same for corners. So the idea is that if you have one edge of your cube here, it can be in any of 12 places because a cube has 12 edges. Yeah. So let's see if we flatten it out as 12 places. Let's see how many is this? 3, 3, 3. I think I did 12. So this edge can be placed in any of these 12 places, right? So for the first edge, there's 12 possible positions. Can you see it, or is it too small? That's fine. Okay.
No, that's fine.
Okay, so how can you count then all the combinations? Because then you need to put a second edge. So the way you can think about it is when you put the first edge, wherever you choose to put it, you have 12 possibilities. So it's like you're splitting into 12 different parallel universes. There's one universe where your edge is in the first place and the others are empty. There's another universe where your edge is in the second place, and so on. There's 12 of them, right? And then whatever universe you're in, you need to put your second edge now. This is the second. And then since one place is occupied, you need to put it in, you have 11 possibilities for your second edge, right? And so each of these parallel universes splits in 11 parallel universes. And so at this second level, after placing two edges, there are 12 times 11 parallel universes where you, of different possible combinations where you might be, right? And you go on like this. So on the third level, there's going to be 10 more possibilities for each of these cases. So you have 12 times 11 times 10, and you go on like this until when you only have one spot left, you need to place your last edge, your 12th edge, in that one spot. So you have only one possibility. Yeah, and you need to take the product each time, right? For each of these possibility, on the next step, there's some more. Yeah, so this number here, I don't remember what it is. I don't remember it by heart. You can do it with a calculator. We also write it as 12 factorial. So we write 12 exclamation mark, which means just a product 12 times 11 times and so on until you get to 1. So it does, when you see a number with an exclamation mark, it doesn't mean like a strong 12. It means this product here. Okay, so this is the basic idea. So now we are only considering edges, but this is not the complete picture, even just for edges, because you see an edge has two colors. Let's take this one. This is red and blue. So it has two sides. It can be red and blue, but I can also turn it like this, and it's blue and red. So if one edge, let me draw it here. Oops. So it can be red, blue, or it can be blue, red. So are these two the same, right? Because I don't know. What do you think? Are they the same?
Probably not if you ask like that.
Yeah. So the thing is, you need we need to agree on what we mean but when we say they are the same, right? Because there's only one piece, which is red and blue in this cube. Any Rubik's Cube you have, there's only one piece that has exactly these two colors. But I can turn it around, right? So it's the same physically, it's the same object. But when I study the combinations, there's actually two of them, the red blue and the blue red. And in fact, when I put back, if I put back this edge into this piece, I could put it back like this, or I can turn it around and have it, whoops, like this. And it's two different cases, right? So the idea is that when I do this parallel universe thing, I said there are 12 possibilities for the first 12 possibilities for the first one, but actually there's, for each of these possibilities, it's actually two of them, because it can be one way or the other. So instead of 12, we have 12 times 2, we have 24 possibilities. And on the second level, there's the same thing, because the second edge also has two possibilities, so it's 11 times 2. And you see, so each of these numbers has to be multiplied by 2, right? So this whole thing, in the end, well, you know that multiplication is commutative. It means commutative, sorry. It means I can do 12 times 2 times the next level times the next level, or I could do first 12 times 11 times 10, and then I multiply by all these number 2s, right? So I need to multiply with 12 factorial by 2 to the 12th power, which means 2 times 2 times 2, 12 times. Yeah, so this is the number of configuration for edges, right? And now, as I said, edges and corners cannot be mixed match. So an edge can only be in an edge position, and a corner can only be in a corner position. So now there's this number here of parallel universes for edge configurations, which I don't know what it is, but if you put it in a calculator, you'll see. And then we see for each of these parallel universes how many configurations for corners are there. And I'm not going to repeat everything, but we could do the same picture for corners. Corners are the ones with 3 colors. So with 3 colors. And there's 8 of them, right? So there's 8 spots. Is it 8? Something like this. There's 8 spots. So you need to place the first corner, and there's 8 times, and then on the second level, you're going to have 7 corners to place. So it's 8 times 7 times 6. It's the same idea, right? You get something similar. So the idea is you get 8 factorial, which is the same notation as before. But again, a corner can be rotated in not just in 2 different ways, but actually in 3 different ways. You see, it can be like with a red here, or you can turn it and you have white here, or you can turn it again and you have green here. And there's only 3 of them, because I can only rotate it. I cannot like take away one part and replace it. So as we did before, when I said 8, actually, I do not only have 8 possible places to put the first corner. I have 8 possible positions times 3 possible orientations, right? So there's a 3 here. And then there's again times 3, and so on. And this is 3 to the 8. Now, yeah, so this is the number of possible positions for corners. And as I said, for each possible position of edges, possible configuration of edges, I can choose any possible position for corners. So the total number of possible configurations for the pieces is, well, this number, the product of these 2 numbers. So it's 12 factorial times 2 to the 12 times 8 factorial times 3 to the 8. So this number here, you can put it in a calculator and you'll see what it is. I do not remember the actual digits, right, that compose this number. I remember this number here because it's written it like this with this formula, because it's very close to the actual process I did to come up with it, right? So there's a catch, actually, but this number is not completely correct, because this is the correct number of possible configuration I can obtain if I remove the pieces and put them back, right? But not all possible configurations are reachable by just moving the sides of a cube. So some can never be reached. I will explain this in a second. I'll try to explain it, but first I want you to see one thing, that there's a complicated number, which is the number of combinations, which I do not remember. But math is not about remembering these numbers by heart. It's about the process to come up with these numbers. So the idea is that, yeah, this is the nice part about math. Maybe what you've seen in school so far is just, okay, this is how you do one thing. This is how you do multiplication. This is how you use this formula to do something. But actually, there's a whole process to finding these formulas, which is very interesting. So yeah. Okay, I said this is not technically the correct number. Unfortunately, explaining why this number is not correct and what is the correct number requires a bit more advanced math, which if you're interested, you can enroll for the Bachelor in Mathematics, because that's something they will not teach you directly how to do this with the Rubik's Cube, but they will give you the theory behind so that you'll be able to do it. But the idea is that there are 3 rules that you never break unless you take apart the cube and put it back. 3 rules, which you can also call invariants. So an invariant is it's a loose term that we use for something that does not change. So for example, if you were the rule of conservation of energy of a closed system, which means that in a physics system would be a mechanical system or particles or stuff like that, the total quantity of energy does not change, right? So it's an invariant. Whatever the system does, it can be that it loses some energy in one place, but it gains it in another place. The total energy is the same. And with a cube, we have some of these invariants, which are not about energy, of course. They're more abstract. Yeah, they are a bit abstract, but we could sum them up like this. One is that there can be no single edge flipped. Yeah, the second one is that there can be no single corner flipped. And what it means is if you give me a cube that has everything correct except one corner which is rotated in place, I cannot solve it. I'll have to rotate the corner, take it apart and put back the corner manually, right? And the third rule is that there can be only 2 pieces swapped. And the idea is, well, the so-called legal configurations. Legal configurations are then, yeah, so it's the number we had before, 12 factorial times 2 to the 12 times 8 factorial times 3 to the 8 divided by, well, we have a factor of 2 because of the first rule. Then we have a factor of 3 because of the second rule, because corners can be flipped in 3 different ways. And then we have again a factor of 2. Yeah, so this is the correct number in the end. Yeah, unfortunately, I don't have enough time to explain why this last part of the formula comes from, but the first part of the formula is very nice to explain, right? Yeah.
All right. And you're not only a mathematician who can solve the Rubik's Cube and explain how it works, you're also a world record holder, right?
Yeah, so I mentioned briefly that there are official competitions with the Rubik's Cube. These competitions are more or less like an athletics competition. So there are different challenges. So for example, in athletics you have 100 meters, long jump, high jump. So we have different challenges. Some of them are different puzzles, like this one or this other one. And some of them are different events with the classical cube. The one I have a record for is actually the only one that doesn't require speed, because it's about solving the cube with as few moves as possible. So the most efficient solution in terms of number of moves. How it works is you have 1 hour and you have to come up with a shortest solution. So you have 1 hour of time, so you can try one strategy. And if it doesn't work, you change, you try something else. Yeah, so it's quite interesting. It's quite similar to solving a mathematical problem. And I solved it once in only 16 moves, which was the best possible solution for that specific configuration. And yeah, it's still the world record.
That's impressive. And who's organizing those events?
So there is an international organization called the World Cube Association. This organization officializes competitions. They coordinate they decide the rules, they coordinate big events. But in the end, it's some local person can contact one WCA official, it's called a delegate, to say, I want to organize a competition in my city. I have a room. Can we do it next month, maybe, or in 6 months?
Mm-hmm. And has there ever been a competition in Luxembourg as well?
Yeah, there's been only one, actually. It was in 2018, so 4 years ago now. Yeah, we were planning to have a second competition 2 years ago. Actually, this day 2 years ago. So this is like 2-year anniversary, second anniversary of a competition that never happened. Because if you remember, like 2 years and 2 days ago, everything closed in Luxembourg and everywhere in Europe, except Italy, which already closed a few days before.
Yeah, I think everyone remembers well. So you're saying we, so you're also part of the organizational team?
So for the first competition that was here in Luxembourg, I just arrived, so I was not part of the organization. I just competed. Mm-hmm. The second competition, yeah, so there's this group of people passionate about the cube. It's called Speedcube in Luxembourg. I hope I did say it correctly. I don't speak Luxembourgish. But organized the first competition, and we wanted to have an event here at the university. So we, in collaboration, I and my professor Antonella Perucca and those people, we collaborated to organize one here. Yeah, which unfortunately could not have. But if you're interested in this a local group of people that plays with the cube and used to organize meetings before COVID, and they will start again probably, you can look them up on Facebook. It's Speedcube in Luxembourg.
Yeah, maybe I'll type it in later as well. And what kind of disciplines can one compete in?
So yeah, there's a total of 17 of them, I think, if I'm not mistaken. Sometimes they add new ones, sometimes they remove less popular ones. Yeah, as I said, some of them are different puzzles and some are different challenges with the same classical puzzles.
And what's your favorite discipline, a part of fewest moves?
Well, fewest moves is probably my favorite. In the past, I was also very good with blindfolded solving, which is solving a cube. First, you look at it, then you memorize it, and then you solve it. I was actually European champion in 2018. Now I'm a bit rusty, but I can still do it.
Yeah, can you show us now?
Yeah, so I have my blindfold here. So, and well, I need someone to mix up the cube for me, because again, I don't want it to look like I'm I'm doing my own moves and then I just do them back. Yeah, thanks. So I explain how it works in competitions. What you do is you receive this cube, which is covered. You start the timer when you start looking at the cube. So it's a bit different. Both the time you take to look at the cube and the time you take to solve it are counted for the final result. And then when you're ready, you put on your blindfold. There's a judge actually putting a piece of paper between your eyes and the cube, so that to make sure you don't cheat. And then you solve it, and when you're ready, when you finished or you think you're finished, you stop the cube. As you can see, as you will maybe see, hopefully not, you can always make mistakes. Yeah, now I will need some seconds, maybe a minute, to look at the cube. I need a bit of silence so I can concentrate. Got it right. Still got it.
That's impressive, really. on the first try. I'd stopped the time just for the solving, and it was 36 seconds. So
okay, I was much faster, but also when I do it in public, I go much slower to make sure I do it. I still can get it wrong, even if I go much slower. And of course, the first time I did it, it took me like 20 minutes, right? And then now I have an official record, which is below 20 seconds. So you can see what just practicing can do.
Yeah, that's really good. So everyone give Sebastiano a warm round of virtual applause. You can find it in the reactions button. Thank you so much.
Thank you.